welcome to the Explainer. So today we're putting on our industry analyst hats. You know, when we talk about the artificial intelligence boom, our minds almost instantly go straight to software, right? The cool new chatbots, the language models, the generative art. But today, we're going to look at the massive, physical, behind-the-scenes reality of AI. This isn't just about software anymore. We are literally talking about the physical pipes of the internet. Which brings up a really interesting question. Is AI computing actually a networking problem? I mean, most people assume the big bottleneck for AI is strictly compute power, like just getting enough advanced processors to crunch all that data. But what industry analysts are seeing on the ground is that AI inferencing is actually just as constrained by the network and memory as it is by compute. Think of it like buying a million supercars, but then realizing you only have dirt roads to drive them on, right? The physical data needs a way to move, and right now, those highways are getting seriously jammed.
And that leads us to this absolute core concept, the networking supercycle. Now, we aren't just looking at cyclical momentum here, where sales go up and down based on the season. No, because AI is forcing our temporary infrastructure assumptions to permanently change. We are standing on the verge of a foundational, massive upgrade to our global digital infrastructure.
Okay, so here's our roadmap for today. We'll start with the networking supercycle, then move into the rise of autonomous agents. After that, we'll cover machine-scale cyber defense, followed by upgrading the infrastructure, and we'll wrap up with the AI workforce paradox. All right, let's dive straight into Section 1, the networking supercycle. Just to really ground this concept in some hard analyst data, 35%. Industry giant Cisco recently reported that their product orders grew by an astonishing 35%. And keep in mind, that's not off some small baseline. That is on a massive $63 billion basis. When an enterprise hardware giant sees that level of rapid growth, it signals an immense demand shock. The infrastructure literally has to be upgraded before the entire market becomes purely supply constrained.
Moving on to Section 2, the rise of autonomous agents.
So we're entering this incredible phase where AI is acting like autonomous digital coworkers. These agents can take on tasks and complete jobs almost fully autonomously. But there's a really sharp contrast in how we humans use networks versus how AI uses them. Think about it. When you or I do a job, we take coffee breaks, we read slowly, we get distracted. Well, agents absolutely don't do any of that. And the crucial takeaway here from analysts is pretty staggering. An autonomous agent consumes 450% more network bandwidth than a human doing the exact same task. 450%. They're just far more consumptive in their usage patterns. You simply need significantly more network bandwidth than what the world historically planned for. Now multiply that 450% increase. The industry isn't just projecting a few of these AI agents. We're looking at a near future where trillions, yes trillions, of digital coworkers will be conducting jobs all over the world. These agents become additional teammates, basically increasing humanity's capacity by 1,000 times. But when you have trillions of agents all drawing 4.5 times the bandwidth of a human, you can clearly see why the old network pipes simply won't survive.
Which brings us to Section 3, machine-scale cyber defense.
So we're moving into what analysts are calling a post-mythos world. This refers to models that can identify system vulnerabilities at just incredibly fast paces. Look, for the last 30 years, bad actors have really had the upper hand, right? Because of one simple rule. They only need to be right once, but the defender has to be right every single time. But post-mythos, we can finally organize security at machine scale. This is a profound paradigm shift. It's an asymmetric move where the defenders might finally have an asymmetric advantage over the adversaries over time. Because AI models can spot vulnerabilities so rapidly, coordinating defense at machine scale actually gives the good folks a crucial time advantage. Organizations can finally flip the script on adversaries. But, and this is a big but, only if their infrastructure is robust enough to actually handle that machine-scale defense. Let's transition to Section 4, upgrading the infrastructure. To make all of this happen, you really have to control the full stack. Let's use Cisco's vertically integrated platform as a prime example of what's required here. You can't just build the software, you need the underlying silicon. You need the optics that communicate data between chips and across data centers that are hundreds of kilometers apart. You need the physical hardware and systems, and then you need the operating systems and security platforms sitting on top of it all. It is a massive, highly complex ecosystem, and the whole shebang has to be upgraded in unison. Up until recently, these constraints were mostly trapped inside massive hyperscale data centers. But inferencing, which is, the AI actually executing its tasks, is shifting really fast right out to the edge.
Imagine a regular worker sitting at their desk with a laptop or Mac Mini, running 100 AI agents simultaneously.
When that level of localized computing becomes the normal way everyone works, it's going to create unprecedented edge traffic. And because of that, an entirely new era of hardware is required. You can't just upgrade the main data center anymore. The entire networking apparatus, from the switches to the routers, the firewalls, right down to the Wi-Fi access points, it all has to get upgraded to handle the heavy inspection and traffic that these trillions of agents are going to generate.
Finally, we land on Section 5, the AI workforce paradox.
Now, there's this huge fear out there that AI is just going to take all the jobs, leaving us staring at the ocean with nothing to do. But real-world data from massive organizations is actually showing a surprising, exact opposite reality. Take Cisco's massive engineering org of over 30,000 people. They're actively using tools like OpenAI's Codex, and they project that by the end of next year, 70% of all their code will be written with AI. In fact, some products are already 100% written by AI today. No way, right?
Well, this leads to a really counterintuitive paradox. With all this code being churned out automatically by AI, it's actually creating more human bottlenecks elsewhere in the pipeline. Think about it. All that code still requires human oversight, strategy, testing, and deployment. So, surprisingly, AI is expected to lead to a net increase in jobs, not a decrease. It's not a deletion of work, it's a massive reconfiguration of how the work is actually done.
And the gap between a worker who knows how to use AI and one who doesn't, it's not just some minor efficiency bump. Analysts point out that the productivity delta between a non-AI fluent worker and an AI fluent worker isn't a 20% gap. It's closer to a 50% gap. People who are AI fluent are going to be in exceptionally high demand, and that trend is going to persist permanently. So we've covered a lot of ground today in this explainer, from that massive 450% bandwidth surge per agent to the asymmetric advantage of machine-scale cyber defense, all the way to the unexpected surge in human job demand. I want to leave you with this final provocative thought. Knowing what we know now about the AI boom moving from the cloud right down to the laptops on our desks, are our current global networks truly ready to support trillions of bandwidth-hungry autonomous agents? The networking supercycle is really just beginning. Thanks for joining me, and keep your eyes on the infrastructure.